Hello students, I am Dr. Vipin B. Gawande and welcome to video lecture series for engineering graphics. In last two video lecture, we are discussing the parallel line development method and we have taken the problems for the cylinder and the pentagonal prism. So now in this problem, we will discuss the parallel line development method for the hexagonal prism. Now the problem says a hexagonal prism is kept on the ground as shown in the figure. So as compared to the previous problem, the theoretical part is not given. Here we have given the front view of hexagonal prism. It is cut by two section planes. So here the two cutting planes are inclined at 30 degree and 50 degree. The location, the position of the cutting plane is given. This is 10 mm from the base and axis height is 55 mm. We have to develop the lateral surface of this prism. Okay. So now by considering the front view of this hexagonal prism, we have to draw the position, that is the top view of hexagonal prism. So how to draw the top view of the hexagonal prism? By just observing the front view. So here there are 1 2 3 4 projections. Okay, now suppose now this is our hexagon. So if I keep this hexagon like this, okay, so how many projections are coming? So if this is the true shape in top view, so 1 2 and 3, so only 3 projections are coming in the front view, but here there are 1 2 3 and 4 projections. That means now we have to keep this on the corner. So if I keep this hexagon on the corner, so then the projections are 1, this is 2 3 and 4. So this is the correct position of the hexagon. So always for all the solid there are two position. One is the edge position, it is resting on edge. If we keep this on the edge, so here we are getting 1 2 and 3 projections, but in the given problem there are 1 2 3 and 4 projections are coming. So this is not the correct position of the hexagon. So we will keep this hexagon on the corner. So if I draw the hexagon on the corner, then the projections which are coming in the front views are 1, this is 2 3 and 4. So this is the correct position of the hexagon. Okay, so we have to draw the top view of hexagon like this, resting on the corner. Okay, so that we have to identify. Now we'll start constructing first the front view. So for constructing the front view, first step is to draw the axis. Okay, so this is our xy axis. We know that this is our vertical plane, here we'll get front views, and this is our horizontal plane, here we'll get top views. Okay, now we'll start constructing the hexagon first, because the problem always start with the true shape. Now here the hexagonal prism is given, so true shape is hexagon. Now how to construct the hexagon? The side is given 20 mm, so take 20 mm as a radius. Okay, so 20 mm distance in compass as a radius. Then draw a circle. Okay, draw the circle of 20 mm radius. Then draw the horizontal diameter, because we want now here it is resting on the corner. So this is the horizontal diameter. Then from horizontal diameter, now take again the side distance in compass. Okay, so 20 mm distance in compass. Then from the two diametrical ends, now mark 20 mm on both sides. So from this diametrical end, two intersection. From this diametrical ends, we will get here two intersection. Okay, so what we have done first, we have taken the side of the hexagon as a radius. We have constructed the circle. We have drawn horizontal diameter because I want it on the corner. Then from these two diametrical ends, mark 20 mm distance on both sides. Now join these intersections, so like this. Okay, so we have drawn the hexagon. Okay, now this is the true shape of the hexagon. Okay, now since this is a prism, so prism means one hexagon is at the bottom, another hexagon at the top. So that means we have to name it twice. Okay, so always in prisms you have to name it twice. So this is A, B, C, D, E and F. This is for the bottom hexagon. Now another hexagon is at the top. Okay, so for that this is 1, 2, 3, here it is 4, this is 5 and 6. Okay, so always remember for prisms we have to name the true shape twice. Okay, similarly for the front view. Okay, now we will find the axis. So how to find the axis now of this hexagon? So to find the axis, it is very simple. Just join the two corners of the hexagon. So here one is the horizontal diameter, you just join another the corners of this hexagon, so we'll get here intersecting point. So that is our the center for this hexagon. Now the axis height is given 55. So take the projections here. Okay, so projection goes up. So this is our axis. So axis height is 55. Okay, so this is 55. Now take the projections. Now since this is a prism, so front view looks like a rectangle. Okay, and complete the rectangle here. This axis height is 55. So we'll complete this. Okay, and there is no projections along the axis, so it remains as a it remains as an axis line. Okay, so that is the center line. Now so we have drawn the front view. Okay, so this axis height is 55. This is 55 here. This is 55. Okay, now we have to construct the cutting plane. So cutting plane is at a distance of 10 mm. So this is 10 mm here, 1 centimeter distance here. Okay, now draw one horizontal line there. Okay, now how much angle we have to take? Here we have to take the angle of 30 degree. So this is 30 degree. Okay. So this is our first cutting plane. So that comes up to the axis. Now the second cutting plane. So that starts from here. It is 50. So take 50 degree angle here. This is 50. Now join this cutting plane. Okay, so this is another cutting plane. So this angle is 30 degree and this angle is how much? This is 50 degree. So we have drawn two cutting planes. One is inclined at 30 degree, another is inclined at 50 degree. Okay, now so the given that front view along with the two cutting planes we have drawn here, we have drawn the true shape of the hexagon also. Now we have to give the nomenclature. So the bottom horizontal line denotes the bottom base hexagon. So this is A dash, this is B dash and F dash, P and F dash, C and E, and this is D dash. Now on the top, this horizontal line denotes the upper hexagon. So this is 1 dash, this is 2 and 6, this is 2 dash and 6 dash, this is 3 dash and 5 dash, and this is 4 dash. Okay, so we have name it twice. So bottom base is A, B, C, D, E, F, and the top base is 1 to 6. Okay, So because it is a prism, so we have to name it twice. Okay, always remember, whenever there is a prism, we have to name it twice. Okay, so we have completed the front view and the top view of the hexagon. Okay, now the basic development. So to draw the basic development, so it is by the parallel line development. So we'll take here 55 mm the parallel line, and okay, so it is up to here. Okay, so take a parallel line to the axis. Now how much the length of the development? So that length of the development is equal to the side the number of sides multiplied by the length of the side. Okay, so it is hexagon, so 6 multiplied 6 into 2, so 120. Okay, so take the side distance in compass, so this is 20 mm. Since this is a hexagon, so we get 6 rectangles. So this is 1, here 2, 3, 4, 5 and 6. So we have drawn here 6 rectangles. So this is 55 here. Okay, and then complete this development. So this is the parallel line development here, 6 rectangles. Okay. Why 6 rectangles? Because it is a hexagonal prism. So for each sides we get 1 rectangle. So now the nomenclature is here, this is A, B, C, D, E, F, and the last one is again A. This is 1, 2, 3, 4, 5 and 6. Last one is again 1, because 1A and 1A will close together. Okay, now how to transfer the points now? Okay, so the next step is now to transfer the intersecting points, or to mark the intersecting points. Now how to mark these intersecting points? So to mark the intersecting points, I have already told you, if the cutting plane intersect the single edge, one intersection. If there are two edges, two intersection. Okay, we will take alphabetically. So this is A, so single edge, so this is P1, single intersection. Now here there are two edges, B2 dash and F6 dash. So we will take B only. So this is P2 for B. So we have taken B, F is remaining, F will take afterwards. After B we have C. So for the C we will take here P3. Okay. For D we will take here P4. Okay. Because it is a single edge. Here there are two edges. We will take E while coming back. So D is over. Now for E it is P5. Okay. And for F, here it is what? It is P6. Because here there is single edge, so single point. Here there are two edges, B2 and F6, though, so there are two intersection. Here there are two edges, so here P3 and P5, two intersections. Here there is single edge, so single intersection. At the same time we have intersection here also, that is on the axis. So we'll name this as, suppose this is X. Okay, so we'll name that as a X. Okay, now so here how to mark this X now? So to mark this X, we will transfer this X intersection in the top view. So this is very important. Okay, now when you transfer this X intersection, so it is intersecting here and here. That means it is intersecting B3, oh sorry, BC and here FE, or 2, 3 or 5, 6. Okay, so it is intersecting like this. So this is, we will mark this as a, suppose X here and Y here. So this is here 2 points, X and Y. Why 2 points? Because it is intersecting two edges. One edge is here and another edge is here. So I have marked the intersection of BC as X and EF as Y. Okay, so we can get the number of intersection for the axis by transferring that in the top view. Okay, we will see how to mark this X and Y. So first we will transfer this, the intersections P1 up to P6. So this is P1 intersection. Now P1 is on A. So this is here and here. So this is P1 on A1. So this is P1 here, this is P1 here. Now P2 and P6. Okay, so P2 is on B2, so this is P2, and P6 on B F6, so this is P6 here. Okay, we'll see, we will left this X and Y, we'll take that afterwards. Now here it is P3 and P5, P3 and P5. P3 and P5 is on C3, so this is P3, and P5 is on E5, so this is P5. Okay, last one is P4. So P4 is on D4, so this is P4. Okay, this is P4. Okay, now what is remaining? This is X and Y. Now X and Y is between BC, so take this distance in compass, BX, take BX distance in compass. Now it is in between BC, so mark it here. Okay, and this Y is in between F and E. Okay, so same distance, so it is in between E and F, so E and F. So we have taken distance from F, so mark from F. Okay, so we have marked that distance. Okay, now draw this vertical line from that intersection. This is vertical line from here, this vertical line from here. Okay, now take the horizontal line from X and Y, which will intersect the intersection in between BC and EF. So this is your X. Okay, in between BC we have X, and in between EF we have here Y. Okay, so that 2 points we have mark. Okay, so this completes our development for this hexagonal prisms. Now the last step is to join these points down. Okay, so this is P1, it goes to P2. Now the another point comes here, that is X. So this is X, then it goes to P3. Okay, then P3 it goes to P4, P4 it goes to P5, P5 it goes to Y, then Y it goes to P6, and from P6 it goes to P1. Okay, and then it comes downward. Okay, and then okay, so like this. So in this problem, so this is the development for the hexagonal prisms with this two section plane. Now in this problem everything is similar to the previous problem. We have marked the intersection according to the number of edges. If one intersection is there, one intersecting point. If there are two edges, two intersecting points. Now the most important part of this problem is this X and Y. How to mark this X and Y? To mark this X and Y, we have transferred that intersection in the top view. We got here that intersection cuts the two edges, so we mark here X and Y. X is in between BC, so we have marked that in between. This is X, we have transferred it, we got here this is X. Okay, so that we have marked. Then Y is in between EF, so we have marked that intersection here. We have drawn vertical line, then we have taken the horizontal line from XY. We got here intersections of X and Y here. Okay, so this is the development for this hexagonal prisms. In this problem, this part is dark, this part is dark, this part is faint, because this part get removed because of these two section plane. Okay, so like this you have to solve this problem. This is another type of problem where the front view is given along with the cutting plane, and accordingly you have to decide the top view. Okay, so in top view we have to see how many projections are coming in the front view. Accordingly we have to draw the top view. So here there are 1 2 3 4 projections, so we have to keep it in a corner. If we keep it on the edge, okay, so yeah, I have already told you, if I keep this on this edge, if I draw the hexagon like this, then here there are 1 2 and only 3 projection. Okay, so then then that is not the correct position of the hexagon. We have to keep it on the corner. So if I keep this on the corner, then only I will get 1, 2, 3 and 4 projections. Okay, so solve the problem like this and draw the correct development. Okay, so thank you very much.